Hello student, I am Dr. Kumar Sinha, Professor of Chemistry. Today I am going to discuss hyperconjugation. Last class I have discussed resonance effect, electromeric effect. Today I am going to discuss hyperconjugation. Hyperconjugation is a general stabilizing interreaction. Hyperconjugation is a general stabilizing interaction. It involves a delocalization of sigma electrons of CH bond, carbon-hydrogen bond, of an alkyl group directly attached to an atom of unsaturated system or to an atom with an unshared p orbital. Here 2-3 points are there, you have to understand here. Hyperconjugation is a general stabilizing interaction, means it will stabilize. Second, it involves delocalization of sigma electrons, means CH bond of an alkyl group. Alkyl like CH3 group, C2H5 group, in that CH bonds are there. Then it involves delocalization, means movement, not fixed. Delocalization, localization means fixed. Delocalization means not fixed. It involves delocalization of sigma electrons of CH bond of an alkyl group. And this alkyl group will be directly attached to an atom of unshared system, unshared, not shared, unshared system, or to an atom with an unshared p orbital. Means this group should be attached with the system where unshared p orbital is there or unshared system is there. There it is, this alkyl group will be attached. The sigma electrons of CH bond of the alkyl group enter into partial conjugation with the attached unshared system. The sigma electron means CH bond, in that 2 electron is involved. Then sigma electrons of CH bond of the alkyl group enter into partial conjugation with the attached unsaturated system. Unsaturated system means maybe double bond or triple bond, or with the unshared p orbital. Hyperconjugation is a permanent effect. Question is asked. Inductive effect is permanent effect, and this conjugation effect or conjugation is a permanent effect. Electromeric effect is electromeric, and resonance both are temporary. To understand the hyperconjugation effect, let us take an example of CH3CH2, means ethyl cation. We should take example of ethyl cation, in which the positively charged carbon atom has an empty p orbital. In this CH3CH2, then CH3CH2, on that carbon is positive charge. It is ethyl group. CH3CH2, on that C, because one H is not there, that's why it is positive charge. Then this we have to understand that one carbon is CH2 carbon is positively charged. That is a cation, ethyl cation, in which the positively charged carbon atom has an empty p orbital. It has p orbital, okay, empty p orbital. One of the CH bond of the methyl group there are three CH bond is there in methyl group. Then one of the CH bonds of the methyl group can align in the plane of this empty p orbital. Means any one will be, you can say, align with the align in the plane of this empty p orbital, and the electrons electrons constituting the CH bond in plane with this p orbital, both will be in the same plane. CH bond and this p orbitals both will be in the same plane, and the electrons constituting the CH bond in the plane with this p orbital can then be delocalized. Means now electrons will move, disturbed, you can say it will be delocalized. Means movement will be CH bond, electron will be in that electron will disturb or will be delocalized. But this CH bond in plane with the p orbital can then be delocalized and move into the empty p orbital. They can come in p orbital, empty was there, there this electron can move. Then here after that what will happen, that this type of overlap stabilizes the carbocation, because in carbocation there plus charge was there, it requires electron, then this CH bond electron, that CH bond electron here just plays a role. This type of overlap, now overlapping will take place with carbon having empty p orbital and that CH electron, both will overlap, and then this type of overlap stabilizes the carbocation which was lacking electron. Now this CH bond will overlap with this p orbital. CH electron or CH bond, electrons involving the CH bond, that will overlap with p orbitals, empty p orbitals. This type of overlap stabilizes the carbocation because electron density from the adjacent sigma bond helps in dispersing the positive charge. Okay, positive charge will be dispersed. Then now what will happen, that ethyl group, that's a CH3 CH2, carbon is positive charge. Then here what will happen, one CH bond of alkyl group, means CH near the this positive carbon, next carbon, one CH bond, that will be disturbed, and that freed from that bond, electron freed from that bond, that will contribute to the, and it will give to the that carbon which was lacking carbon, first carbon, it will give electron to the first carbon and it will form double bond, and hydrogen will be freed, CH bond, that bond broken. Then H became now without electron, means H plus, means no electron, H has no electron, and this 2 electron which was involved in CH bond, that has overlapped with p orbital. Then now this single bond became double bond, and now that positive charge gone, carbon positive charge gone, and H plus charge just means went far from that carbon because that bond broken. Then now only CH2 is remaining In the second carbon, only CH2 is remaining, third hydrogen gone. And second carbon also CH2 only. Okay. Now, same situation will happen because 3 CH bond is there. In second carbon, 3 CH bond is there. Then what happened with the first CH, second and third? It can also take place in the same way, provided they should be in the same plane. Then with second, if second suppose a bond, second bond CH bond is going to be disturbed, then that hydrogen will go and electron freed from that bond will take part in the formation of double bond between carbon and carbon. In the beginning, carbon and carbon single bond was there and carbon was having positive charge, first carbon. Now due to this breakage of or this bond breakage, that hydrogen gone and 2 electron they have given to the, or this 2 electron made the bond between carbon and carbon positive charge gone. Then like that way same thing will repeat. This is possible with all 3 CH bond. Any one, not all 3, any one by one they can give. Anyone can give. Once 3 possibilities are there with first CH, second CH, third CH. Then like that way you can say 3 structure is possible. First you have seen one bond broken. If that bond will not break, then second structure you can show that second CH bond is breaking. And then third also you can show third structure in third CH bond can break. Okay. Then like that way 3 structure is possible, and where bond is breaking, hydrogen you can write only that place without bond. That hydrogen H plus will be there without bond. Then all three structures are, you can say, reversible. Means first structure can make second structure. Means one bond broken and H became H plus and CH2 is formed. Now again same type of structure, third structure, then now second bond will break and hydrogen will be there only as a H plus. Now again CH2 will be there. Third CH bond can break, then H plus will be there. Again CH2 will be there. Then all structures are reversible. Reversible sign you can give, means one bond and both end arrow sign will be there. Okay, means first can convert to second can convert into the first. Okay, both arrow shows like that, one line and both end one arrow will be there. Then again second and third same way, same sign, arrow sign, both side arrow sign will be there. And again second and third. Correct? Then like that way 3 structures are there, positive charge. Now all hydrogens are getting separate positive, but at a time only one. All 3 possibilities are there that you are showing in 3 structure. That's why this is getting this due to this now this ethyl cation is getting stability due to the formation of double bond. In general, greater the number of alkyl groups, again important point, in general you can tell greater the number of alkyl group attached to a positively charged carbon atom, the greater is the hyperconjugation interaction. The greater is the hyperconjugation interaction and stabilization of the cation, which was now C plus, that are getting stabilized due to hyperconjugation. This is called breaking of CH bond. Breaking of CH bond, and that electron will involved in making the double bond with p orbitals of the positive carbon atom. That is called actually hyperconjugation. Then three possibilities is there, CH, CH, CH. Three bonds are there. Then any one can break. Then there are three possibilities. That's why it is stabilized. This is called conjugation effect or conjugation. Then greater the number of alkyl groups attached to a positively charged carbon atom, the greater is the hyperconjugation interaction and stabilization of the cation. Thus, we have the, you can say, relative stability of carbocation. I am talking about now this relative stability of carbocation. Means here, if you can say carbocation, cation I am talking about from that carbon which has C plus, 3 CH3 is attached. 3 CH3 methyl group is attached, CH3, 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 because it is cation, C plus is there. Then this cation is stabler. This cation is stabler than 2, when there is only 2 CH3 is attached. Here 3 CH3 is attached. That's why it is stabler than CH3 whole 2 CH. When only 2 CH3 group is attached. Third one is H only. Then CH3 whole 2 CH. That is weaker than first one. Means CH3 whole 3 C plus, you can tell. CH3 whole 3 C plus is stabler than CH2 whole 2 CH. That was only C, now it is CH. And this is a stabler. Second is a stabler, means CH3 whole 2 C plus H is stabler than CH3 CH2. Only one CH3 is attached, and in the place of 2 methyl, 2 hydrogen came. Now it became CH3 CH2, and C has 1 plus. No, everywhere C has 1 plus. And this is again, you can say, stronger than CH, CH3, you can tell. CH3, C is 1 plus. C has 1 plus. Then C has 1 plus every cases. But if more methyl group means more stable. More methyl group means more stable. And in first case, 3 methyl group was attached with C plus. Hence it was stabler than second, where only 2 methyl groups attached. And this is stabler than when 1 methyl group is attached. And this is stabler than no methyl group is there. Only CH3 is there. Means last will be the weakest and first will be the stabler, you can tell. This is the weakest last, CH, only C, no methyl group is attached, because then there will be no hyperconjugation, hence it will be not stable, least stable, and highest stable is first one, where 3 methyl group is attached. Hyperconjugation is also possible in alkene and alkynes, where double bond and triple bond is there. There also hyperconjugation can take place. Hyperconjugation is also possible in alkenes and these things, alkyl arenes, not alkyne, alkyl arene. Means arene means here you are talking about benzene. With benzene, CH3 group will be attached. CH3 will be attached. Alkyl arene. Then in this both cases also hyperconjugation take place. In case of alkenes, why? Because now in alkenes double bond is there. Then they can make triple bond. Due to the pi, one empty will be there, pi bond, that can again, if CH3 is attached there, then say, due to the same reasoning, same hyperconjugation, again triple bond will be formed, means double bond will become triple bond. Then here also it is possible. Delocalization of electrons by hyperconjugation in the case of alkene also is possible. Okay, and you can show it also. Suppose now double bond was already there, already told you. By structure also you can see that in if you want to show the double bond between carbon and carbon in case of alkene, then you have to write that time you have one sigma bond will be there, in alkene double bond is there, then one sigma bond and one pi bond will be there, then one sigma bond easily you can make. Okay, that is due to the end-on overlapping or excess-wise overlapping of orbitals. Then that is the sigma bond. 1 electron, both orbitals will have 1 electron, both carbon will have 1 orbital, axis-wise or end-on. Then they will overlap and they will form sigma bond. Overlapping is more, that's why sigma bond is stronger than pi bond. And on each carbon pi this pi bond will be not pi bond, pi orbital will be there on each carbon. Then they will overlap, sidewise overlapping or lateral overlapping. Due to lateral overlapping or sidewise overlapping, this pi bond will be formed. Because overlapping will be less, that's why bond will be weak, and that is the reason pi bond is bigger than sigma bond. Question is asked. Then 2 bond is there. Now suppose with this ethylene, third carbon is attached, which has 3 CH, means 1 methyl group is attached with this ethylene. Then again same thing will happen. CH bond will break and that electron, 2 electron will be freed. That electron can you can say make bond with where second double bond is there, that triple bond will be there. Okay, there it can make triple bond. Then like that way delocalization of electrons in the hyperconjugation in case of alkenes takes place. There are various ways of looking at the hyperconjugation. You can see in a various ways. This is also called hyperconjugative effect. This hyperconjugation is also called hyperconjugative effect. One of the way is to regard CH bond as possessing partial ionic character. Okay, one way you can see that CH bond, one of the way is to regard CH bond as possessing partial ionic character, not full. It is covalent. But hydrogen, that is that it can give electron easily. Then CH bond actually is this is the covalent, but not fully. It is, you can tell, it is a partially ionic. Actually, if any electron will be fully transferred, then it forms ionic bond, complete transfer of electron. Due to complete transfer of electron, it forms ionic bond. And if there is a not complete transfer, just only displacement is there, some displacement is there, but more than in covalent sharing of bond, sharing of electron will be there. Then due to the sharing, it forms a covalent bond. But now if little more sharing is there, more displacement, then ionic character will come. Some partial ionic character will also come. Then CH bond has a partial ionic character also. You can understand like that also. Then one of the way is to regard CH bond as possessing partial ionic character due to resonance. Means you can this you can write ethylene that is the double bond is there, CAC double bond is there. Then one carbon will have 2 hydrogen and other will have 1 hydrogen and other you can say 1 hydrogen and 1 methyl group. Ethylene has 2 carbon, then 1 carbon has 2 hydrogen, and both have double bond in the middle. And second carbon, it is attached with 1 hydrogen and with 1 methyl group. 1 methyl group means CH3. Then CH3 means CH. 3 CH bond is there. Then like previous what I told you, that can make a triple bond. Double bond will come triple bond. Then there also you can tell that this is happening due to the ionic character, partial ionic character of CH. Okay. Then because in that way you know that H will form H plus and carbon will take both electron, and that can give to the nearer can say adjacent carbon and can form one bond. That is now double will become triple. This is the one way I told you. Then like that way 3 structure is formed. 3 structure is formed means if carbon double bond means ethylene. If with ethylene CH3 group is attached, then again 3 structure is possible, what I have discussed earlier. Then now every time any one CH bond will break and it will form H plus and bond will be not there and new bond will be formed. When one bond is CH bond is breaking, that bond will be not there, only H plus will be there. Near the carbon only H plus. Means any time it can make a bond also. Okay, or because it is a positive charge, hydrogen will have positive charge, carbon will have negative charge, partial negative, and they by the attraction they will be there. Then when first CH bond, suppose it is any one will break at a time, then suppose CH bond is breaking, then H plus will be only there and that electron, freed electron will make third bond. Then double bond become triple bond. Like that way you can say second structure, second ACH can break now. Then again triple bond will be formed and H plus will be only there. Where it broken, it will be only there as a H plus. And like that way third structure, third CH may also break. All are the possibilities, hence all 3 structure you can write. But always you have to write only 3 bond, triple bond. And that hydrogen will be only there, H plus. But no bond, it will be near that only. And triple bond will be formed. Then this when you consider as a partial ionic charge, then you have written like this. Both you have written in the same way. Only difference is that in that first case only one carbon, one C plus was there, in that one CH3 was attached with one carbon which was having positive charge. With that CH3 was attached in the first case, and here ethylene is there and again one CH3 attached. Then all things happen same way, only double will become triple, double bond will become triple bond. Okay. Then like that way you can say all 3 structure forms. And bond where it was the double bond, they will make triple bond. In all cases triple bond. But here what will happen, that where it was the first, where it was the this double bond, Now that from that one bond shifted to the nearer. Means a bond was a double bond was there with carbon 1 and carbon 2, and third carbon was attached. Then in the beginning, double bond was between carbon first and carbon second, but now due to hyperconjugation, now bond form between second and third, and second became second means what was the initially, that became single bond. Means first carbon became single and second carbon became double. In the beginning, carbon first and second, between carbon first and second double bond was there. That is called actually carbon 1. It was the double bond, and that time carbon second was single bond. Now carbon second became double and carbon 1 became single, and one pair of electron will be there with negative charge near that carbon, because bond broken and a new bond formed. Then if you will write triple bond, then okay. Otherwise, if you write only double bond, then one pair electron will be one pair electron will be there with the first carbon with negative charge, if it is making only double bond. Otherwise, if you are writing triple bond, then no, these two electron will be there. No two electron, because this two electron can make one bond, but now CH is there. CH2 was there, then that one H gone. Means just to 4 valency of carbon you have to maintain. 4 valency of carbon you have to maintain. For that reason, 5 valency can't be there carbon. That's why carbon will have one electron. A pair of electron first carbon will have. Otherwise, it will be this rule of tetravalency will be violated. Okay. Now all are showing carbon second is, now it is showing tetravalency, because double bond is there, carbon double bond, and right side also with one carbon is attached, 3 bond, and one hydrogen is attached. Okay. Then same structure is for all. First carbon single bond, second carbon double bond, and first carbon was having 2 electron with negative sign. Then this I told about the hyperconjugation effect. Now one problem is there. This can be asked. The hyperconjugation may also be regarded as no bond resonance. One more, this is again important things I am telling you. The hyperconjugation may also be regarded as no bond resonance, because H plus was there, but this H plus is not attached with the carbon. It will be only simply it will be there. Then this is also considered as a no bond resonance. Now I am telling the one problem which is asked in examination, or further also may be asked in exam. Question is that explains why CH3 C plus is more stable than CH3 CH2 1 plus and C plus CH3. Only CH3 is there and CH1 plus. Okay. Explain why CH3 Now you are understanding. CH3 C plus means 3 methyl group is attached with C plus is more stable than. Now only one CH3 is attached with C and 2 hydrogen is there. Means CH3 C has 1 plus and H2 is there. CH3 CH2 means cation, ethyl cation. Okay, and why it is stabler than methyl cation, means CH3 1 plus. Why CH3 is the least stable, and first one CH3 is more stabler than stabler than CH3 CH2 means ethyl. Okay, ethyl cation. Then its answer is very easy. Hyperconjugation interaction. Hyperconjugation interaction in CH3 whole 3 C plus is greater than CH2 plus. CH3 CH2 means ethyl cation. Hyperconjugation interaction in CH3 whole 3 C plus is greater than in ethyl cation. Ethyl cation means CH3 CH2. C is plus 1 plus CH2. As the CH3 whole 3 C has 9 CH bond. CH3 3-methyl group is attached with the carbon. Then each CH3 has 3 CH bond. CH3 whole 3 means 3-methyl group is there. Then each methyl group has 3 CH bond. Then there are 9 CH bonds. Okay, that's why hyperconjugation will be more. That's why it is a stabler. Great. It is a you can say most stable, you can tell. Most stable out of 3. In CH3 1 plus means methyl cation, what is there? In CH3 1 plus, vacant p orbital is perpendicular to the plane. Perpendicular to the plane, not in plane. Perpendicular to the plane in which CH bond lie. CH bond is there. In CH3 also CH bond is there. But these are p orbitals are perpendicular and these CH bonds are in plane. That's why they are not making, conjugation is not going on. In CH3, vacant p orbital is perpendicular, 90 degree upside, perpendicular in the plane in which CH bonds lie, hence cannot overlap with it, because p orbital is upside, perpendicular, and these are in the plane, hence overlapping will not take place. That's why it is a least stable. And CH2, I told you, this ethyl cation is the middle. Okay, thus CH3 lacks hyperconjugation, hyperconjugative stability. It is a least stable. This I have told you about the these things. Hyperconjugative, due to the hyperconjugative effect, some molecules will be stabler, other will be weak. Now, types of organic reaction mechanism. Actually, all things you are studying under the mechanism only. Organic reaction mechanism, all things are studied because all are related to the breaking of bond, forming new bond. Always the bond which is weak will break first, and bond which are stable will not break, or it will break in the end in a very special condition. Then now you can say different type of organic reaction that we will discuss. Then here all things in the beginning you will not study all the things in details. Only at the right place I will tell you in details. Now only I am telling the name of different reaction or types of organic reactions and mechanism. Just I am telling the name. At the right place I will go in details. Okay. Then first type of organic reaction is substitution reaction. Substitution reaction means that one will go and other same type of group will come. One group will go and same type of other group will come in its place. Substitution. Correct? Suppose that there was a group of there was a 6-membered ring, or else suppose a 6 students were there total, including boys and girls, 6 students, and one boy just went, and its place other boy came. This is substitution. Or any one girl went, and in her place other girl came. That is substitution. Then in organic reaction, sometimes one group will go, or one atom will go, and similar type of atom will come. Suppose one electronegative atom is going, then other electronegative atom will come. Correct? That is called substitution. As for example, in the place of chloride ion, bromide may come, iodide may come, like that way. Chloride may come. All are electronegative. Then substitution means that. Then first type I told you, I am given only hint. Right place I will tell in details. That is the substitution reaction. And second type of common reaction is addition reaction. Addition reaction means, by name it is clear. Two parts will add. And a long part will be formed. As for example, CH3, CH3 1 plus is there, and other suppose C2H5 is coming. If both will add, then now in the beginning it was CH3, now it is C2H5, then total 3 carbon. Total they will join, and it can form due to the addition. Always addition time, one will be carbocation, other will be carboanion. Sometimes due to some circumstances, carbon will have positive charge, then it is called cation. Sometimes carbon will have negative charge, then it is called carboanion. Carbocation, carboanion. Then one is positive, other is negative, both carbon will join and will make one bond. Then now it becomes long chain. Then this is the example of addition reaction. This is called addition reaction. Now third example is elimination reaction. Elimination, eliminate. Then here sometimes during the reaction, that when only in the same branch, only in the same molecule, same compound, sometimes when you can say H and Cl will come close, then it will form HCl gas and it can go. Then bond will be broken. H and Cl both will interact. Then they will form HCl, and H was attached with the carbon. Then leaving one electron on carbon, H gone, H as H plus. Cl taken one electron and it became minus. Then that carbon will lack now electron, because electron was taken by chloride, taken by chlorine, you can tell. Then H plus and Cl minus, Cl became Cl minus. Then now both form HCl. HCl is a gas, it will go, and it in the place H when that time one electron it left, then that carbon will become positive, and this not here. H when H plus went, then carbon became negative, having electron was there, because it left 2 electron, because one bond, in formation of one bond 2 electrons are there. Then H gone without electron as H plus. Then now 2 electron is there, that 2 electron will be given to that carbon, where from that carbon Cl has gone by taking its electron. Then now one bond will be formed between these 2 carbon. If it was in the beginning single bond, then now it will become double bond, and HCl went outside as a gas. Then this HCl eliminated eliminated means it went out from the molecule. Then like that way, other example in that you can tell, suppose in one carbon, nearest carbon, adjacent carbon, one carbon OH is there, other carbon H is there, then both will form H2O, H plus OH, same way. H will break as H plus, OH will take the electron as OH minus, and H2O. Then now it will go as a water molecule, it will go out, eliminate. And H gone without electron, that then there it is, that carbon will have electron, one pair of electron, and other carbon is lagging because their OH has taken electron and went, then that carbon become plus. Then this electron will give 2 electron and they will make bond. Adjacent carbon, it will happen in the adjacent, nearest carbon. Then this type of reaction is called elimination reaction. Now fourth type I am telling you, rearrangement reaction. Rearrangement reaction. Then rearrangement reaction means here actually all things I am telling you, this rearrangement also takes place in the same molecules. In the same molecules. How? Then sometimes will happen, suppose OH group is there, OH group is attached in this molecule, in this compound, in any compound, suppose OH molecule is attached. Then if you can say due to the internal rearrangement near the OH, with COH was there, now due to internal rearrangement with the carbon H has gone, H came to the carbon, then that time it was the, you can say, OH group. Now you can say due to the rearrangement of bond, now I told you that OH group was there, but now when one H will come there, then there some you can say bond rearrangement will take place. Now C and O was having single bond, COH, then O was attached with the carbon, one single bond, and other it was attached with H, hence O and H one bond and O and C other bond, correct? COH, then O and H single bond, and C and O and C single bond, means oxygen in the middle. Oxygen is making bond with carbon and oxygen is also making bond with hydrogen, oxygen in the middle. This was in case of OH, COH. But now if one hydrogen will come near the carbon, then what will happen? That oxygen will make double bond. Oxygen will make double bond. Each H will go from the O and will come near the, now it was attached with oxygen. Now due to some circumstances, if this H will come and attach to the hydrogen, then now carbon will have you can say 2 hydrogen, okay, or you can say new hydrogen came and attached with the carbon, and carbon oxygen became double bond. Then now here it was now alcohol, now it became carbonyl group, carbonyl CO group, or you can tell CHO group, aldehyde group. In aldehyde group, CO is the carbonyl group. Then this CHO group, due to the internal arrangement of bond in the same molecule, in the same compound having 2-3 like carbon is there and hydrogen is there, it means all tetravalency of carbon is there. Hydrogen is attached. Then now see, in the beginning only OH was there, but now after that due to internal arrangement, now that became OH group became CO group. Alcohol group COH, now it is in the CO form or CHO form, aldehyde group. Then this is called rearrangement reaction. and I will tell you details, further details in the right place. Okay. Now I am telling you other things. Method of purification. Methods of purification of organic compounds. How, suppose compound form may not be pure. Some impurities may be present, some other compounds may be present there. Then how will you purify? That is very particularly in organic compounds or organic reaction. That time they will form sometimes at a time 2 product will be there, 3 product will be there. Then this product, one product may be in more quantity, other product may be in less quantity. Then with the main product, other product, byproduct, what we are telling, may be mixed, may be present. Then in that way, I can say you have to purify the organic compound. You want only main product. You don't want byproduct. You want to remove that. Then how will you purify? Then this is done by many methods are there. Then that I will tell methods of purification of organic compounds. Once an organic compound is extracted from a natural source, sometimes from natural source also you can obtain. Organic compounds also can be obtained by natural source. Natural source means from the tree, plant, like that way. That is a natural source, trees and plant. Then once an organic compound is extracted from a natural source or synthesized in the laboratory, it is essential to purify it. It is essential to purify it. Various methods used for the purification of organic compounds are based on the nature of the compound and the impurity present in it. What type of impurity is present there, accordingly you have to use the methods. As for example, some is suppose with the main compound some impurities are there, and this is such type of impurities that if you will heat, then without converting to the liquid, it will vaporize. It will vaporize, it will go outside, leaving the main product. Then like that way, purification can be done. Then this type of process is called sublimation. Sublimation. Then here, sublimation, the purity of compound is ascertained by determining the melting or boiling point. You have to also decide according to the melting point or boiling point. But before going somewhat details, I want to tell you name of the methods. Then first method is sublimation. Second method is crystallization. Third method is distillation. Fourth method is different extraction method, differential extraction method. And fifth method is chromatography. Again I am telling you, first method you can tell, these are the common methods: sublimation. Second is crystallization. Third is distillation. Fourth is differential extraction method. And fifth is chromatography. These are the 5 common methods. Finally, the purity of a compound is ascertained by determining its melting or boiling point. Most of the pure compounds have sharp melting point and boiling points. This is the characteristics of a pure compound. Every compound, here very important things I am going to tell. Every compound has a fixed melting point and boiling point. Every compound. fixed. It will not match with others. If suppose you got two compounds and both have same melting point and boiling point, it means both are same. It means both are same. Hence, this is also important factor, melting point and boiling point. New methods, other methods I am talking about, new methods of checking the purity of an organic compounds are based on different types of chromatographic or spectroscopic techniques. Other methods are also there. There is a new method based on chromatographic or spectroscopic technique. Now I will tell you little these things about all the things, methods. Then now first we come to the sublimation. Sublimation. What is the sublimation? I think you might be knowing. Just now I told you also, if you will heat, on heating some solid substance, change from solid to vapor. It will change from solid to vapor state without passing through liquid state. This is called sublimation, and substance is called sublimate. The purification technique based on these principle, above principle means sublimation, you can tell. This based on the sublimation principle is known as sublimation and is used to separate sublimate compounds from non-sublimate impurities. Suppose non-sublimate and sublimate both are mixed, then if you will heat, then non-sublimate will not, nothing will happen, and which is sublimate, they will go directly in vapor state, leaving the non-sublimate. Hence easily you can separate it. And crystallization, this is all are important. Crystallization is very, very important. Then what is the crystallization? By the name it is clear that it will form the crystal, process of crystal, that is called crystallization. Then here what will happen? This is one of the most commonly used techniques for the purification of solid organic compounds. It is based on the difference in the solubilities of the compound. This is the important thing. How this will separate by crystallization? Then it is based on the difference in the solubilities of the compound and the impurities in a suitable solvent. Suppose a compound, you want to separate it from the impurities. Then now you have to consider, you have to dissolve it in the solution, solvent. Then here what will happen? The impure compound is dissolved in solution in which it is sparingly soluble. Here the impurities in compound is dissolved in a solvent in which it is sparingly soluble at room temperature. It will dissolve, and other will not dissolve, means pure compound will not dissolve, impure will dissolve in solvent. One suitable solvent is required. In that impure will, that is impurity will dissolve in that, and other will not dissolve. Then now you can separate it. Then it will come out as a crystal, pure crystal. Then this is important. The impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature, but appreciably soluble in higher temperature. In less temperature it will not dissolve, or very less will dissolve, but at higher temperature it will dissolve completely. Okay, less temperature it will dissolve very less, or it will sparingly soluble, what I told you, and at high temperature it will dissolve, impurities will dissolve more. The solution is concentrated. In that way, solution is concentrated to get a nearly saturated solution. If we will heat it, then solution will become saturated. The solution is concentrated to get a nearly saturated solution. On cooling, when it is hot, when you will cool it, then what will happen? On cooling, the solution, pure compound, crystallizes out. It will come out in the form of crystal. Crystal will be means always pure. On cooling the solution, in solution both are present. Impure solution is also present, pure is also present. Means a pure compound and impurity both are present. Then on cooling the solution, pure compound crystallizes out and is removed by filtration. But that will not crystallize. Impure substance will not crystallize. Only pure substance will crystallize. Pure compound crystallizes out and is removed by filtration. The filtrate, that is called mother liquor. What is left out liquid? Left out liquid is called mother liquor. The filtrate, that is called mother liquor, contains impurities and a small quantity of compound also may be present, a small quantity. If the compound is highly soluble, soluble in one solvent and very little soluble in another solvent, crystallization can be satisfactorily carried out in a mixture of these solvents. Then that time also it can separate. If suppose in a little compound is remaining in the mother liquor, then that also can be separated, that in which impurities is soluble but compound is pure what you want, that compound is in you can say not soluble or less soluble. You can separate it also. If the compound is highly soluble in solvent and very less soluble in another solvent, then that type of solvents are used. Means crystallization can be satisfactorily carried out in a mixture of these solvent. Impurities which impart color, suppose it is colored solution, impurities is suppose it is in the colored form, then how will you separate? Impurities which impart color to the solution are removed by adsorbing over activated charcoal. Actually, if you will pass this solution, colored solution is colored, you want to remove the color, then you have to take that time charcoal, activated charcoal, and if you will pass this mixture, if you pass this colored solution, then color will be absorbed by the charcoal, activated charcoal. Then repeated crystallization becomes, this first I understand, impurities which impart color to the solution are removed by adsorbing over activated charcoal. Repeated crystallization becomes necessary for the purification of compounds containing impurities of comparable solubility. Supposed to come with the compounds and impurities, if solubility difference is less, solubility difference is less, not too much difference in solubilities, then many times you have to crystallization you have to do. Then always pure compound will separate out and impurities will be in the solution. Okay. Then this I have told about the these things, crystallization. And now distillation, I want to tell you what is the distillation. Then distillation, this is very, very important process. The important method is used. This is a very important method also, like crystallization. This method is used to separate first volatile liquids from non-volatile impurities. There it is used. Second, in the liquids having sufficient differences in their boiling points. If two liquids are mixed and boiling point differences are more, then there it is used. Liquid having different boiling points, liquids having different boiling points vaporize at different temperature, and that can be separated. The vapors are cooled because at a different temperature they will vaporize. Then whatever vapor is coming first, that you cool it, then that is separated. The vapors are cooled and the liquids so formed are collected separately. Then both liquids will be separated. Correct? This chloroform, I am giving example. As for example, chloroform, its boiling point is 334 K, and aniline, its boiling point is 457 Kelvin. Then suppose both are mixed, then one chloroform 334 Kelvin. If you will heat, it will vaporize first. Then this vapor you collect and cool it. Then you will get the liquid chloroform separate, and this aniline will be left in that flask. In the flask both were there, both aniline and chloroform both were mixed, and if you heated this flask through condenser, name itself is a condenser. Condenser means here vapor will condense, because that condenser, through condenser, because through that condenser liquid cold water will be passed through from the upper layer. This HL2 layer will be there. From the inside layer, inside hot vapor will be there, and above this layer, one layer will be there. In that cold water will be there. Then upside cold water, and inside tube, from the inside, and from the inside tube vapor will come. Then that vapor will come cool, and vapor will become liquid, and that you can collect it. In the other container you can collect it. Okay. Then like that way you can separate. That chloroform, its boiling point is less. Then at 334, in that flask thermometer will be there. By you can measure the these things, temperature also. In cork, thermometer will be fixed. It will be dipped in the solution. Then when it is boiling, that temperature also you can note down. And that vapor 334, up to 334, whatever vapor is coming, you pass through the condenser. Condenser is cold from the outside. From the inside vapor is there. Then vapor is becomes a liquid that you can separate out. This method is called distillation, and other liquid aniline will be only in the flask. That again you can separate it. Then this is the one example I told you that this can be easily separated by the technique of distillation. The liquid mixture is taken in a round bottom flask and heated carefully. On boiling, the vapors of lower boiling component are formed first. The vapor are condensed by using a condenser, and the liquid is collected in a receiver. The vapors of higher boiling component form later, and the liquid can be collected separately. Okay, this I have told you about the this thing. Three technique I told you: sublimation, crystallization, distillation, and what is remaining I will discuss in the next class. Thank you.